Welcome back again. Today we are going to look into a more deeper section. So consider the question given there. A steel solid shaft transmitting 15 kW at 200 rpm is supported on two bearings 750 mm apart and has two gears keyed to it. The pinion having 30 teeth of 5 mm module is located 100 mm to the left of right hand bearing and delivers power horizontally to the right. The gear having 100 teeth of 5 mm module is located 150 mm to the right of the left hand bearing and receives power in a vertical direction from below. Using an allowable stress of 54 MPa in shear, determine the diameter of the shaft. So first we have to understand the problem carefully. Now the given data is P is equals to 15 kilowatt, N is equals to 200 rpm, AB, that is the distance between two bearings, is 750 mm, TD is 30, that is teeth of pinion is 30, module of pinion is 5 mm, PD is 100 mm, TC, teeth on gear is 100 and its module is 5. Then AC is 150 mm. Shear stress is 54 MPa. We know that the torque transmitted by the shaft T is equals to P into 60 upon 2 pi n. So substituting the values for it, we will get T is equals to 716.197 Newton meter. Now we know that the diameter of gear D is equals to number of teeth on the gear into module. So that implies the radius of the gear is equals to TC into modulus upon 2. So we get radius is equals to 0.25 meter and radius of pinion is equals to TD into MD upon 2. So which is equals to 0.075 meter. Now assuming that the torque at C and D is same, therefore tangential force on the gear C acting downward, FTC, is equals to twice of T upon diameter of the gear. So which will be equals to 2864.788 Newton. So we are approximating it to 2870 Newton, and again by the same procedure the tangential force acting on pinion D, that is acting horizontally, is given by the same formula, and the value we obtained is 9549.2933 Newton, which is approximately equals to 9550 Newton. Now let us find the maximum bending moment for vertical and horizontal loading. First of all, considering the vertical loading at C, let RAB and RBB be the reactions at the bearings A and B respectively. We know that RAB plus RBB is equals to 2870 Newton, as we can see in space diagram also. Now taking moment about A, we get RBB into 0.75 is equals to 2870 into 0.15. So RBB is equals to 574 Newton, and from this we can get the value of RAB by substituting the value for RBB. So we get the value of RAB is equals to 2296 Newton. Now the bending moment at A and B is equals to 0. So we will calculate bending moment at C. So MCB is equals to RAP into 0.150. That is the force and this is the distance. So which is equals to 2296 into 0.150. So from this we get the answer 344.4 Newton meter. Similarly, bending moment at D. So we obtain the value for bending moment at D is equals to MdV is equals to 57.4 Newton meter. Now considering horizontal loading at D, let RAH and RBH be the reactions at the bearing A and B. We know that RAH plus RBH is equals to 9550 Newton. Now again, taking moment about A, we get RBH into 0.75 is equals to 9550 into 0.75 minus 0.100. So the value we obtained for RBH is equals to reaction, that is the horizontal reaction at B is equals to 8277 Newton. And by substituting this value in the above equation, we will get the value of reaction, that is horizontal reaction at A. So the value we obtained is 1273 Newton. Now again calculating the bending moments at C and D. First of all, we know that the bending moment at A and B is equals to 0. Now calculating bending moment at C. So MCH is equals to RAH into 0.150. So the bending moment at, that is the due to bending moment at C due to horizontal reaction is 190.95 Newton meter. Now similarly calculating the bending moment at D, we obtain the bending moment at D is equals to 827.7 Newton meter. Now the resultant, we have to calculate the resultant bending moment. So resultant bending moment at C is given by MC is equals to under root of MCV square plus MCH square. From this we obtain the value for bending moment at C is equals to 393.7 Newton meter. Similarly calculating the bending moment at D, we obtain MD is equals to 829.69 Newton meter. Now we can see that the bending moment is maximum at D. So therefore M is equals to MD is equals to 829.690 Newton mm. Now let D be the diameter of the shaft. So the equivalent twisting moment TE is equals to under root of M square plus T square equals to, so we obtain T is equals to 1098.011 Newton meter. Now this equivalent twisting is given by pi by 16 tau d cube. So from this we will obtain the diameter which is equals to 50 mm. So hence this is the answer. We have solved the numerical. Now look at the diagram shown below. Subscribe to our channel and for free notes visit cart2galaxy.com. Thank you.